All right, well, good morning, everyone, and welcome to the 2025 HyperX Users Conference. Introductions, we always forget to do this, but I'm Ivonne Collier. For those who don't know me, I'm founder, engineer, and senior vice president at Collier Aerospace. 2025 is the company's 30th anniversary. I guess you may have heard that or picked up on it by your shirts that we gave you with the 30th on them for most of you. But it's a big deal for us, and we are honored to share this year with you guys, and it just worked out very well that you could be here for this milestone, so thank you. So we have 115 people here, I believe, and I want to thank you. First of all, a great big thank you to every one of you. This was hard to make, I know. It's not easy, and for attendees, thank you for making this a priority in your career to be here and learn everything you can about HyperX. For the speakers, thank you for the hours and hours of prep and practice and Zooms and reshuffling your decks. That's not easy either, and it's not lost on us. We do appreciate you. So you made it here. Storms in Charlotte last night. Some flights were missed. Some people will get here a little bit late, but you're here. Enjoy your seat. Take a deep breath, relax, and just get ready to absorb all the information that's coming your way. Guests, grab your notebooks that are in your conference bags. These are our little commemorative notebooks for you guys. And we'll put your name in them probably because there's about 100 of them here. And write your notes, write questions for your speakers, which speakers love to hear questions and answer them, I think. And jot down any aha moments you have when you hear about how someone else is using HyperX. So what is HyperX? It is kind of a hard thing to answer. I'm going to play you a 90-second video, and let's take a look.
What is HyperX software? HyperX is a commercial software product that automates your stress analysis and design optimization. Starting with your FEM and FEA results, HyperX calculates margins of safety by comparing the applied FEM loads to your allowables using classic aerospace techniques. It then determines the lightest weight cross-section that attains positive margins to all load cases and updates the FEM accordingly. This process allows you to instantaneously trade materials and panel concepts, refine cross-sectional details, and design joints without having to resubmit the FEA each time. As the structure matures, HyperX designs the part as a manufacturable whole, readily communicating to CAD platforms. Throughout the design process, the HyperX database is the one source of truth for sizing results and margins of safety for your team. HyperX is an essential part of the digital thread and the center of your airframe analysis and design process. HyperX, center your design.
If you ever have to present what HyperX is to your company, that's always available to you on our website. It's at the bottom of every footer, and it talks about, there's the what is HyperX, and you could just get right to that and share that. Next, before we kick off the day, I want to point out a few key locations in the building that you're going to want to know about. We have the Pearl Young Theater. This is our home base for the 2 days. We've got our little C there with the red box around it. And we have restrooms to the left and the right of our theater. And there's a NASA gift shop that's, I think, open 11 to 2 each day, right across from those restrooms. Right outside of this theater, you'll see a snack area under the stairs. You all had coffee there. We're going to have food, snacks throughout the day changed out. And if you want something different, you can go to the Splashdown Cafe, just to the right as you exit this theater. There's also a soundproof booth in there, so if you need to take a really private phone call, you can go in their soundproof booth. It's super cool. I want one at home. Cafeteria is available, but for us, we are having a private lunch in the NACA room, nod back to the NACA days, and we will cut through the cafeteria, or through the dining area rather, and go to the end of the hall. A little sneak peek for tonight. If the rain clears up, which I think it will, We're doing it anyway, so it doesn't matter. But this is a look at last year's. This was the 2023. We do these every other year. HyperX Users Conference. We met at the James River Country Club, doing this again tonight. If you arrive by bus, the bus will take you there, and the bus will take you back to the hotel at the end of the evening. The sunset hopefully will be beautiful, as that bottom right picture shows. James River sunsets are amazing. And here are a few more pictures from last year. It's just a great time to socialize, network, and just hang out, get to know each other, and make some bonds with each other that we'll carry back to our stress community. If there's something we've learned, is that it is a small community, and you will run into the same people over and over throughout your career. Before I start, I want to let you know that today and tomorrow we have an amazing lineup of speakers. Thank you again to all the speakers coming out from companies. It's not easy to get permission. It's not easy to get travel approval. All the things are tough, and we know what you've been through, so thank you. Before we begin, though, I want to take a glance back at the last user conference, and we had 3 speakers I want to highlight. The first speaker I want to mention is Ryan McLaughlin. At the time, he was a structural engineer for Trek Bikes. He's also a competitive cyclist. You'll see his photo there underneath his headshot. He walked us through the process of designing high-performance racing bicycles, and think price points of $10,000 to $50,000. This is, not your everyday bicycle. He contrasted the before and the after of learning about and using HyperX software at Trek. And funny story, he now works for us. He's in the room. Ryan? There he is. Woo! And so his flight was canceled the last user conference because of bad storms like last night. And we said, hey, just stay for our annual company river party. Our company and spouses and kids and dogs, we all get together on the river. And that was it. So we're very happy to have him with us. And you will hear Ryan. What's that? Oh, you will hear Ryan speaking these 2 days. As an example, I picked one. He showed many slides, but he showed us, you think, okay, just a bike, right? But no, he showed us the challenges of extremely complex curvature in bikes. With HyperX, he told us that Trek was able to define the true fiber directions, which was actually a really big deal for Trek. And the Trek presentation was a crowd favorite. Next, we have Rick Young, right here at NASA Langley. He's the manager of 2 projects. The first is the NASA ACP, which is the Advanced Composites Project. That was a $173 million project right here at NASA Langley, and it ran through 2019. And Collier had a really key role in the ACP. We were the only software providers on the project, and all of the members were able to use our software, which was great. The purpose of that was to reduce the time to develop and certify composite structures. The second project is the NASA HiCam, which is High Rate Composite Aircraft Manufacturing. This one is a $320 million project, and it continues through 2028. Partners include NASA, the FAA, Boeing, Lockheed, Aurora, and Collier Aerospace, and a few others. The purpose is to enable high-rate production, pushing the output in the U.S., I think Boeing, is good to be something like 80 per month. And the third speaker you may remember is Mike Kirsch, Deputy Director of the NESC, the NASA Engineering and Safety Center. Funny story, I was talking to him in the hall as he was passing through, and I said, hey, I'm going to quote you. He goes, well, I'm staying. So he's here today. Thank you, Mike. NASA, and the NESC is independently funded by the NASA Chief Engineer, who reports to the very top of NASA directly, which is the NASA Administrator. So therefore, they are outside of any program, and they get called in on special things. They have 60 badged people, and they call in subject matter experts on each of their 1,200 assessments plus by now. And that is how Mike brought Craig in. The NESC asked Mike to lead an agency team to design, build, and test a composite crew module. And I'm going to quote Mike here. Now, I can't officially endorse Hypersizer because that's ethically forbidden. But I will tell you, I put Collier Aerospace on contract because I wanted that tool and I wanted the expertise from the Collier team to help run it. And indeed, we leveraged the heck out of that tool as we optimized different configurations. We carried the hypersizer model through manufacturing and test. We demonstrated the predictability of the design through strains at ultimate design loads. We eventually took the structure to failure, which occurred above predicted damage-tolerant ultimate design loads. All of this was documented in a series of NASA reports that was shared publicly with industry, and the final report emphasized the benefits of having used the hypersizer tool, end quote. A couple of years later, Mike got a call from the Orion program chief engineer. Go figure, he said, the Orion has a weight problem, and what space program doesn't? So Mike told us, quote, once again, I put together a team of structural designers from across the agency. But most importantly, I called Craig. Now officially, I'm not endorsing hypersizer, but I told him, dude, I need you, and bring your software. So the point in my two stories is that we leveraged the expertise that came from Craig and his team. And if you called me again tomorrow for another design, I would call Craig again. Again, I don't endorse hypersizer officially, but if you want to know where my priorities are, follow where I spent my money, which is kind of true in life, right? And Mike's final slide, which is probably why, one of the reasons I picked this one to focus on, was that his final slide really made an impression on me. He emphasized the importance of what we do as structural engineers every single day and every decision we make. Mike said, quote, today is a new record for NASA in human spaceflight. Yesterday, too, NASA lost its first crew in the Apollo 1 fire in 1967. 19 years later, we lost the crew of the Space Shuttle Challenger. 17 years after that, we lost the crew of the Space Shuttle Columbia. Today, we are 20 plus years from that Columbia accident, and every day is a new record. Think about what's going to happen in 20 years. Many people that were involved in previous accidents, and they stated unequivocally, I will never let that happen again, have now retired. Over time, we are at risk of slowly losing the engineering rigor it takes to prove that hardware is behaving in a predictable way. Throw in the commercial model, where NASA is buying a ride. And now we need to assert our engineering rigor, and it becomes even more difficult. Getting to space takes enormous energy, and that energy has to be managed appropriately. The environment is completely unforgiving, and flying crews based on, it's probably okay, is just not good enough, end quote. And thank you, Mike, for that. It's a good reminder. HyperX is in a position to preserve and protect that engineering rigor that Mike emphasized, and to protect it for generations to come. Thank you for listening today, and I hope you enjoy the next couple of days, and I look forward to meeting with each and every one of you at some of the breaks or tonight at the social. And to end off this afternoon, right after lunch, I'm going to take you on a trip to Mars, so don't miss it. Thank you.